Let's look at some aspects of waves and the vocabulary we use to describe waves. We'll begin with amplitude. Amplitude can be said to be related to the energy of a wave, and we see it as the distance matter moves from the equilibrium position. So let's look at our equilibrium position, and then we would show amplitude as how high or how low a wave is at any one point relative to the equilibrium position. So the amplitude of this wave is shown here. The displacement from the equilibrium position is amplitude. Let's say that the green wave has a relatively big amplitude. What would a small amplitude look like? A small amplitude would look like the orange displacement from the equilibrium position, where the amplitude is much smaller from here to here and here. Our next concept, let's consider frequency. Frequency is a count. It's the number of waves that pass a particular point in a time frame. We represent it with the letter F. Next, we'll talk about wave speed. You know speed to be distance in a ratio with time. As always, we'll use the letter V for velocity. The distance a wave travels is something known as wavelength. And the time a wave travels is known as period. Since wavelength is a distance, what exactly is a wavelength of a wave? Here we have, beginning from an equilibrium position, a displacement for this transverse wave back to equilibrium position, and a displacement in the other direction relative to the equilibrium position down. This is what makes up one wavelength. We use a symbol lambda to show wavelength. We also use a capital T for period. That is the time it takes to complete one full wave cycle, or one wavelength of energy to pass. If we go back to our definition of speed, we can see that we can write this as a formula as wavelength over period, lambda over t. This gives us two important equations as we work with waves. And the first one, of course, is our velocity, is wavelength over period. And if we go back to frequency, we find that it is the number of wavelengths in a time. So we can define frequency and period relative to each other in that period is the inverse of how frequently a wave travels. Or perhaps it's easier to say that the frequency of a wave is the number of waves in a time period, or the time it takes for one wave to go by.